Today we're going to talk about modeling integer addition on a number line. So we're going to use what's called a vector to help us model, and it's basically a line with an arrow just on one end. Okay? So what we're going to do is if we're going to model -2 plus 3 on a number line, that's going to help us find the sum. And remember, the sum is the answer to an addition problem. Okay? So what we do is we place the tail of the arrow, the first arrow, on 0. So we always start at 0. Okay? Always start at 0. All right, so then we're going to draw the arrow 2 units to the left because we have a -2, so we're going 2 units to the left of 0. 2 units to the left of 0 would get us to the integer -2. The direction of the arrow is going to be to the left since we were counting down from 0. So my arrow is going to point to the left. We're going to start a new arrow. Our next arrow is going to be at the end of the first arrow, which was at -2. My second arrow is going to be 3 units to the right since we're counting up. So this arrow is going to point to the right because it was a +3. This time, I'm going to count over 3 spaces starting at -2, and I would end up stopping at 1. So we're going to practice that down here. And then it says to circle the number at which the second arrow ends to indicate the ending value or the sum, the answer to the addition problem. So again, we're using this -2 plus 3. So I'm going to start at 0, and because my first integer is -2, I'm going to go to the left 2 places, and when I get to -2, I make my arrow. Next, I'm adding a +3, so I'm going to start above the -2, and I'm going to count over 3 places. 1, 2, 3, and I'm going to draw my arrow, and then it says to circle the number where the second arrow ends, and that's my answer, that's my sum. So this is how we would model adding integers on a number line. So let's look at the next one. I have a +3 plus -2. So my first arrow is going to go to the +3. So I start at 0, and I'm going to go over to +3, and when I get there, I'm going to make my arrow. Now I'm adding to it a -2, and negative numbers go to the left. So I'm going to start at +3, and I'm going to move to the left 1, 2 places and make my arrow. And then I circle where I left off at. So it says, what can you say about the sum of -2 plus 3, that was our first one, and 3 plus -2, that was our second one. And what do you notice about those? Yeah, the sum equals 1 on both of them. So does order matter when you are adding? Well, this time I went -2 plus 3, and down here I went 3 plus -2. So when we are adding, no, the order does not matter. And you guys might remember learning in previous school years about the commutative, I think I spelled it wrong, property. And the commutative property says that if you are adding or multiplying, it doesn't matter what you do first, you'll get the same answer. So will the models look the same? The models, no. Our models didn't look exactly the same. This one started on the left, and this one started on the right. So no, one started on the left, and one started on the right. So they didn't look the same, but I still got to the same answer, as long as I kept my negative sign with the correct number. Okay, let's go ahead and flip that over and we're gonna look at some more examples. What I would like you to do is pause this video, work out this example, whether it's in your notes packet or on a separate sheet of paper, and then start it up again and see if you got the right answer. You can do that for both of these. All right, so for this one, I'm starting at -6, so I'm gonna start at 0, but I'm gonna go to the left 6 places. And I'm adding to that a +4, so now I have to go backwards 4 places. So 1, 2, 3, 4. And I'm gonna circle my final answer. So -6 plus 4, my sum is a -2. My next one, I have a +3 plus a -8. So I'm gonna start at 0 and go to the right +3, because positive numbers are to the right of 0. And now from my +3, I need to move backwards or to the left -8 places. So there's 1, 2, 3, 4, 5, 6, 7, 8. And my final answer, can you hear my dog down there wanting some more food? My final answer is a -5. So a +3 plus a -8, stop it, gives me a -5. This example shows arrows already written, and notice there are 3 of them, so that means it's representing 3 different numbers. And it wants you to figure out which integer each of these arrows represents. So we would do that by, this one started at 0, and it looks like it came over to 5. So this arrow would represent a +5 or 5. Then it looks like from 5, I jumped back 2, so going backwards 2 would look like a -2. And then this one, we started at 3, and it looks like it ended at 6, so 1, 2, 3. So this one moved 3 to the right, so that's a +3. So now it says, what is the addition problem? So we're going to take each one of these and we're going to make it into an addition problem. So you could have 5, I added to that a -2, and then I added to that a 3. What is the sum? Well, I went over 5, back 2, and to the right 5 again, and if I follow this arrow down, looks like I landed on +6, so the sum would be 6. This next question says, would the sum change if we changed the order in which we add the numbers? So I want you to pause this and think about this for a second. Would we get the same answer if I did it in this order as I did this order? So go ahead and pause it and work that out. So it said, would the sum change? No, it wouldn't. Would the model change? Yes, because in this model, I would start to the left first and only move right. And in this model, I started to the right, went left, went right. So yes, one would start going right, and one would start going left. However, we would get the same sum, the same final answer, because of that commutative property that tells us it doesn't matter what order you add or multiply, you're going to get the same answer. Feel free to rewatch this video and relook at these notes anytime that you need to remind yourself on how we model addition using number lines.